Yes, good evening. So this is lecture 2, and it's on rational and irrational numbers. Yeah, so this is MSM 1, and my name is Hamted. Yeah, so today we're going to look at the set of numbers. And then on these sets of numbers, we only take rational and irrational numbers. All right, let's proceed. So if we remember what we learned yesterday, I think we all remember to say we said we talked about rational numbers and also we talked about irrational numbers. We defined them and we also defined other types of numbers. And now today we're going to look at rational and irrational numbers in details. So we know to say every rational number can be expressed in the form A over B, where A and B are members of integers. Remember what we said yesterday? We said this Z here represents integers, rather it denotes integers. And then we know to say in this fraction A over B, B will never be equal to 0. And then we know to say A and B are all co-prime factors. So now you might be asking yourself, what is a co-prime factor? So a co-prime factor is just the other way of saying A and B here. Yeah, it's just the other way of saying A and B. A and B are in their lowest forms. Okay. Let me just do this. Just want to avoid sound from WhatsApp. Okay. All right, proceed. So I was saying co-prime factors is just the other way of saying A and B there on this fraction are in their lowest terms. Yeah. So this statement here, this definition for rational numbers is very important. It's very important when if you want to know whether the fraction that you've been given is either a rational or an irrational number. Let's proceed. So these are examples of rational numbers. We said they are fractions, and these fractions, A and B, are always in their lowest terms. We know to say these numbers A and B, these numbers A and B are members of integers. So if we say they are members of integers, it implies that they can be what? They can either be negatives or positives. And then we know to say B should never be equal to 0. So meaning the denominator here will never be equal to 0, but the numerator can be 0. There's no problem. Let's now look at irrational numbers. So irrational numbers is just the opposite of rational numbers as we defined it yesterday. So we know to say every irrational number cannot be expressed in the form A over B. And then in other words, or the other way you can define an irrational number is that this is a set of all real numbers excluding a set of rational numbers. So in short, when you take all real numbers and then you remove, and then you out of the real numbers you remove you remove rational numbers, the set that you remain with will be called an irrational, and yeah, the set that will remain will be called a set of irrational numbers. Sorry. Let's proceed. So these are the examples of irrational numbers. Yeah, you can see there the root of 2 is an irrational number, the root of 3 is an irrational number, the root of 5 there is also an irrational number, and the root of 6. But how do you know that the root of 2 is an irrational number? How do you know? Can you just guess? No. Let us now look at the methods of identifying or the methods of showing that a given number is an irrational number, yeah, or a given number is not an irrational number. Let's look at this method here. So yeah, before we look at the methods, let's first look at the rules of irrational numbers. We look at the rules, yeah, we go through them. So we know to say the addition of two irrational numbers result into an irrational number. So in other words, this first rule here is telling us to say when you add two irrational numbers, you are going to have your answer to be an irrational number. And then when you subtract, the subtraction of two irrational numbers will also result to an irrational number. So when you subtract two irrational numbers, your answer will still be an irrational number. Yeah. Let us proceed. Rule number 3 says, when you multiply or divide two irrational numbers, the results will either, this is supposed to be will, yeah. Okay, yeah, it's okay like that. I was using my English to define it. So what I'm saying, when you multiply or divide two irrational numbers, the result will either be irrational or rational, depending on the kinds of numbers that you've been given to multiply or divide. And then here you can see to say the addition and subtraction of an irrational number and a rational number results to an irrational number. So in short, when you add an irrational number or with just any other number or with a rational number, your answer is going to be an irrational number. When you add an irrational number with a rational number, the result will be irrational. I think these are the only rules that you need to know. You need to know these very much, because if you don't know these, four rules here, it will be difficult for you to prove the irrationality of any given number. So let us take a look at this example. This is example 1. So example 1 is saying, show that the root of 2 and 1 plus the root of 2 are irrational numbers. There's supposed to be S there. I'm going to include it before I send it to you. So we're saying, the question is saying, show that the root of 2 and 1 plus the root of 2 are irrational numbers. So how do you do that? Remember what we said. You first have to know those 4 rules which I gave you, and for you to tell whether the given number, for instance, the root of 2, for you to tell whether the root of 2 is rational or irrational, you have to know the definition of a rational number or an irrational number. What is this definition we're talking about? Let's look at this. Yeah, before you look at the definition, sorry, I forgot to talk about one thing, the method by which you can show that this is irrational or rational. So in this video or in this lecture, I'm going to show you the simplest way you can prove any given number, whether it's irrational or it's irrational. And in most universities, this is the recommended method. And this method is none other than the contradiction method. So we're going to use contradiction method to prove whether, or to show whether the root of 2 and 1 plus the root of 2 is rational or rational. So by contradiction method, so from just this word, contradiction. So when we say we're using contradiction, meaning we're going to assume, we're going to make an assumption to say the root of 2 is rational. So now what happens when we make that assumption? Let's take a look. So let us assume that the root of 2 is rational. So if the root of 2 is rational, this simply means that the root of 2 will be equal to A over B And then where a and b are members of integers and b is never equal to 0, a and b are called prime factors. So you remember what I said, for you to answer questions on rational and irrational numbers, you need to know the definition of an irrational number or the rational numbers. You need to know the definitions. If you don't know the definitions, it will be very difficult for you to prove this. So what I've just written here, let me just be pointing there. So what I've written here is just the definition of a rational number. So what I've written there is just the definition of a rational number. So now let's proceed. So from here, what we do is you are going to now take this part here. You're going to take this part. Then what do you do with this part? So I'll write it here. The root of 2 is equal to a, sorry for my handwriting, a squared, oh sorry, not squared, let me just write it properly. So I'm going to copy this. It's going to be the root of 2 is equal to a over b. So I've just copied that. Okay. So now, having copied that, we now have to do what? We now have to square. In short, in other ways, we have to simplify this expression. How do you simplify it? You square both sides. For you to get rid of this side on this left side, you square it. And then the way an equation is, according to the rules of mathematics, if you square one side, it also means that you also have to square the other side. So when you square these sides, you're going to have this, the square root of 2 squared there, you just remain with 2 being equal to, when you square a over b, you're going to have a squared over b squared, like that. Okay, so here it's just a matter of cross multiplying. When we cross multiply here, we're going to have 2b squared being equal to a squared. And then from there, after doing this, what you do now is you take a look at your expression, which is this expression here. You look at it now, observe what is happening here, because a lot of people just miss it just here. So observe what is going to happen here. Look at this. When I multiply 2 times b squared, when I multiply this 2 times b squared, I'm getting a squared. Don't you think that for me to get b squared, I have to divide a squared by 2? I don't know if you have gotten me here. So in other words, I'm trying to say this 2 is a factor. So this 2 is a factor. I'll be just writing a short form here, but you should be finishing it when writing. So this 2 is a factor over, so this 2 is a factor of a squared. In other words, 2 can go into a squared. How many times? B squared. And if you are just good at mathematics, you can prove and you can attest with me to say, if this 2 can go into a squared, it also implies that these 2 can also go into a. So meaning 2 is also a factor of, so 2 is also a factor of a. So if 2 is a factor of a squared, it also means to say 2 can also go into a. It's just the same as saying if 2 can go into what? If 2 can go into 6 without leaving a remainder, it also means that if we square this 6 and then divide it by 2, these two, this is a square, these two go into the answer there on top without leaving a remainder as well. If 2 is a factor of 6, 2 is also a factor of 36. I'm sure maybe some of us have gotten it, that if you haven't, you just come and try to go through the video. I'm sure you're going to get something. And then, yeah, so here, what I'm trying to say is 2 is a factor of a squared. This 2 is also a factor of a alone. So now, if this 2 is a factor of a, if these 2 can go into a, it simply means that when you multiply these 2 by a certain number, you are going to get, so this number I've just denoted it by k. So if you multiply these 2 by a certain number k, or a certain constant k, you are going to get your answer to be a. In this case here, our constant was b squared, but in this other case we don't have anything, so we're just going to introduce another letter, which is k. When you multiply these 2 with k, you get your a. I hope we're following. And then apart from that, from here, now you can get this same expression here. I'll just show it with an arrow like that. Yeah. So this same expression, where there's a, I'll replace with 2k, since I know to say a is equal to 2k, and then a squared is equal to 2b squared. So I'm going to write 2b squared is equal to, where there's a, I'm putting 2k. Where there's a, I'm putting 2k. So I'm going to square this. So when I square that, I'm going to have something like this: 2b squared being equal to 4k squared. So when you divide these, or when you divide both sides by 2, you're going to have b squared being equal to 2k squared. So what this simply means is that, okay, in short, we've just gone to an expression which looks similar to this one here. Now, in this case, we are dealing with b. So what I mean by that is that this 2 is a factor of, okay, this 2 is a factor of, this 2 is a factor of b. This 2 can also, is a factor of b squared. This 2 is also a factor of b. So now, if 2 is a factor of b and 2 is a factor of a, when you look at these two statements here, these last two statements, this one and this one, we're saying 2 is a factor of a and 2 is a factor of b. So meaning 2 can go into a and b. This is what it means. So in writing, or in conclusion, you can say, since 2, it's just that writing here with the mouse is very difficult. So I'm not going to be writing the full statements. If you have where to write, you can just be writing what I'm saying. So in conclusion, we are going to say, therefore, since 2 is a factor, therefore since 2 is a factor of both A and B, therefore since 2 is a factor of both A and B, this contradicts with the fact that A and B are co-prime factors. This contradicts with the fact that A and B are co-prime factors. Anyway, if you didn't have time to write, you're going to write. I'm going to send this video. You write the statement so that you think, I don't know, you think about it, you see what I'm trying to pull out of this. Since this is contradiction method, so in short, we're just trying to find a mistake in any of what we've been given in this definition of a rational number. We have to find at least one point which is contradicting with this definition of rational number. And in this case, we have discovered that 2 can go into B, 2 can also go into A. But in the actual sense, for this root of 2 to be a rational number, A and B are supposed to be in their lowest terms, meaning there shouldn't be any number that is supposed to go into A and B, apart from A and B themselves. So, since 2 can go into both A and B, it simply means that these 2 points are contradicting with the fact that A and B are supposed to be co-prime factors. All right. You go through the video if you've not understood. I'm going to send the video. Go through it and try to understand what I'm trying to talk about here. And then apart from that, I think on this one, after just writing that conclusion, it simply means that you have shown to say the root of 2 is an irrational number. Let's move on to this part here. Do we have any questions on the root of 2 before we proceed? So this root of 2 will not always be root of 2. Sometimes they'll bring root of 5, root of 6, they'll bring root of 3, root of 7, you prove. So let us now continue. Proceed. So here we are now going to 1 plus the root of 2. So 1 plus the root of 2, we're trying to show whether it's an irrational number or not. We're trying to show that it's an irrational number rather. So here, since we have already shown to say the root of 2 is an irrational number, and we know according to the 4 rules here, there's a rule which says the addition of the last rule here, the 4th rule here, it says addition and subtraction of an irrational number and a rational number results into an irrational number. And then when you look at this here, we have this rational number which is 1. We also have this irrational number which is 2. When you add them, the answer gives us an irrational number, which implies to say this 1 plus the root of 2 is an irrational number. So when you are given such a question, what you do is just prove to say, or you just prove, or you just show that the root of 2 is an irrational number, and then you conclude to say, since the addition of a rational number and an irrational number results into an irrational number, it simply implies to say 1 plus the root of 2 is an irrational number. All right, let us now proceed. I'm sure you've gotten something here. If you have not gotten it, I'm going to send the video. Don't worry, you watch. You go through it at your own time and you understand. Okay. So now let us now look at rationalizing numbers. How do you rationalize numbers? In other words, when we say rationalize numbers, we're trying to say show that the given set of numbers or the given decimal numbers are rational numbers. And how do you show that? It's by changing them, rather expressing them in the form a over b or in a fraction form, because all rational numbers can be expressed in a fraction form where a and b are co-prime factors, and then a and b are members of integers, and b is never equal to 0. Just remaining with 10 minutes. Anyway, if time finishes, I'll ask maybe 10 to 20 minutes from you guys. I'll generate another link, then we just finish up what is going to remain. But I just pray that we finish this before even the 10 minutes elapses. All right, so we proceed. So the repeating decimal numbers. So we're going to be expressing the repeating decimal numbers as fractions. Here is a question. It's saying, convert the following decimal numbers to the form x over y in its lowest term. These are the simple questions that confuse a lot of people in exam rooms. You find this as question 1, everything, all the exam paper becomes sour. These are simple questions that confuses a lot of people. So pay particular attention on these questions. So these are the two questions we're going to start with. So here I'm going to solve them bit by bit. I'll start with A. So A is saying 0.54. So here what is repeating is what is repeating there is 54. 54, 54, it goes like that. How do you convert this to a fraction form? So the way you convert this, by the way, when this is repeating in other ways, you can just put a bar on top there to show that these are the numbers that are repeating. For instance, here 3 is repeating, so I can just put a bar on 3 to show that 3 is the one that is repeating. So I'm going to say let x, so I'm going to say let x be equal to what? 0.54 bar. So what will happen here, or the first step, is to move the point closer to the repeating numbers. And then how do I do that in this case? My point here, the decimal point, is already closer to the repeating numbers. So meaning there's no need of me doing that. Then the second step is that I'm supposed to move the decimal point to cover all the repeating numbers. So if I move 2 steps this side, or if I move, I don't know how many steps this side, I'm also supposed to add 2 zeros to the one which is the coefficient of x this side. So I'm going to move how many steps? For me to cover 54, I'm going to move 2 steps. So when I move these 2 steps to bring the decimal point here, it simply implies that just here we know to say this 54 is repeating, so meaning they are to my 54 here, going 54 here, they are going like that. So now I've moved this decimal point like that. So after moving it, it's going to be, so this side, I'm going to add 2 zeros to the 1. So I'm going to add 2 zeros since I've moved 2 steps there. Then this is what I'm going to have. So I'm going to have 54 0.54 like that. So let me just erase this. Okay. All right. So after doing this, here it's just a matter of subtracting. So what do? We subtract. 100x minus x, I'm going to get 99x equals this 54.54 bar minus 0.54 bar. It's just a matter of cancelling this, because this minus that will give us 0, meaning after the decimal points we're going to have zeros. So 54 minus 0 there, I'm just going to have 54 there. So x is just equal to 54 divided by 99. But remember what the question says here. In its what? Lowest term. So meaning I have to convert this in, I have to change this into its lowest term. I have to reduce it. I don't know which number can go there. I think 3. 3 into 5 there is 1. 3 into 24 is 8. Then we have 3 into 9, 3. 3 into 9, 33. 3 can still go there. 3 into 18, 6. 3 into 33, 11. So this is our number. Try to punch this on the calculator just for the sake of proving. You see if you are going to get 0.545454554. Yeah, you can try to prove that. Okay, let us proceed. Oh, sorry. This is an exercise. So we proceed. We move on to B. So we move on to B. So even B will do the same way. You just follow the same steps. We have 3. So this is B. We have 3.61. Then we have these 3 repeating. So we put a bar on top. So you say let x be equal to 3.613 bar. So the first step, I said you move the point closer to the repeating numbers. So I'll move the point closer to the repeating numbers. So this point is going to move how many steps? 1, 2. So it's going to move two steps. So I'm going to have 2 zeros being added to a 1 this side, and then x, which is equal to, so I'm going to have 361.3. These 3 will go like that. Yeah. So here again, I have to move this point in order to cover one of the repeating numbers, or to cover all a set of repeating numbers. So in short, what I'm trying to say is that I'm going to move, since 3 here is just the only number that is repeating, so I'm going to move 1 step to cover it. 1. So even this side, I'm going to add 1 0. So this is going to be 1000x being equal to 361 3.333. So here it's just a matter of subtracting. So when we subtract 1000 minus 100, you get 1000 minus 100, you get 900. 900 is equal to, so you subtract 3613 minus 361. 361. Remember, these repeating numbers here will just cancel themselves when you subtract. So you just subtract the numbers in front. So you are going to have 3252. You're going to have 3252 like that. So here it's just a matter of dividing. Oh, there's supposed to be x here. It's just a matter of dividing by 900. Even this side you divide by 900. And then when you reduce this to its lowest term, you are going to have, yeah, I think you can reduce that. You can reduce that. Yeah, you can reduce that. So you find the number that can go into 3,252, and this, yeah, due to time, since the meeting will soon end, you can go and reduce that. It's part of your work. Finally, you can go through the video if you've not understood what I've done here. If you still can't understand, you can ask me on WhatsApp, text me, I'll explain. Yeah, so I've put the work here which has to be submitted before the next lesson. Yeah, so I'll send a slide. So make sure that you answer this work before the next lesson. Thank you very much for attending the lecture. Due to time,